Good evening, everyone. Welcome to Conservation Conversations. My name is Ed Pritchard, and I'm with Miami Eco Adventures, a division of Miami-Dade Parks, and a co-host of this webinar, along with UF IFA Extension and Florida Sea Grant. It's great to see some of our returning participants tonight, and for those that are new, welcome and thank you for joining us. We are happy to bring you these monthly webinars covering a wide range of environmental topics. And we have a great lineup this spring, including tonight's talk on green energy. A few housekeeping items before we get started. So everyone in this webinar is currently muted, and we ask that you guys stay that way throughout the talk. If you have any questions that come up, please type them into the chat. They'll go to our host tonight, myself and Anna, and we'll go ahead and answer those at the end of the presentation. We will also, as a reminder, this webinar is being recorded, so we will be sending out a link to that recording so you can share that with others, or if you miss a little bit, you can always watch it later. If you do enjoy these webinars, we encourage you guys to follow us on social media at Miami Eco Adventures and at Miami-Dade Sea Grant. And of course, if you want to find out more about the topics or get more or get our lineup for the spring, you can email Anna. She'll put her email in the chat now. So without further ado, we'll go ahead and get started. So feel free to settle into the couch, enjoy your dinner, and listen to this great presentation we have in store for you tonight from Allie King. Allie, take it away.
All right. I'm Allie King with Miami Eco Adventures. So I am going to talk to you tonight about green energy. This is a topic that is near and dear to my heart. I drive a plug-in hybrid, so I pay a lot of attention to electricity and energy. But first, before we get started, I want to know what you know. So we have some little questions and a poll for you to start out. Asking about whether it's true or false that nuclear power creates low air pollution emissions, or most Florida electricity comes from what? Biomass, natural gas, nuclear, or solar. And 3, small solar arrays on individual houses won't have an impact on climate change. True or false?
So I think we pretty much got everyone. So we're going to go ahead and finish this poll in a few seconds. Thank you guys for participating in that.
All right. And we will have the answers to that at the end. So what is green energy? There's no definitive definition of green in any field. It's generally something that is considered to be good for the environment, but what good for the environment means really depends on the company or organization that is calling something green. There's no one thing that makes something green, so it's really left up to the consumer or the person to decide for themselves whether or not they think something is green. In the energy field, it is equally confusing, and there is debate about what is and isn't green. But in general, everyone accepts that fossil fuels are not green. So that's coal, oil, gasoline. All of those fossil fuels are not considered green. But what is considered green? There are some differences of opinion. But before we get into that, where does our energy come from? So this is a graph for the United States showing the primary sources of energy. You can see that petroleum and natural gas make up the biggest slices of that pie. And you can also see that most of it is not, most of those sources are fossil fuels. So 79% of where our energy comes from fossil fuels. The red section that shows petroleum, and a lot of that petroleum goes towards transportation, so cars, trucks, planes, etc. But most of the rest of that energy goes towards making electricity. And especially right now, as gas prices are going up, everyone is thinking a little more about using gas-powered vehicles, right? It's very expensive at the pump right now, and it looks like it's only going to keep going up. And so as electric cars and electric vehicles gain popularity, even more of this is going to go towards electricity, and hopefully less is going to go towards that petroleum section. But so then that makes you wonder, where does our electricity come from? So this is a chart from the EPA's Power Profiler. It's a tool that's available online that basically will tell you what the fuel mix is in different parts of the country and compared to nationally. So the graph on the bar on the left shows that national fuel mix, and the bar on the right shows just for Florida. And when you look at them side by side, you can really see that Florida has a lot of fossil fuels. So those orange and gray sections, more than the national average. So that's 62% nationally and 85% for Florida. So that's a lot larger percentage that is fossil fuels here in Florida. But that's not the whole story. Now, if you're going to be comparing fossil fuels, natural gas is a much cleaner burning fuel than coal. If you look in that yellow box, you can see the emission rates for Florida. Those are the emission rates for Florida right there. And you can see the emission rates for CO2, so carbon dioxide, sulfur dioxide, and nitroxides. But when you compare Florida to a part of the country that gets most of their electricity from coal, you see those emission rates go way up. Coal has a lot more CO2, it has more sulfur dioxides, more nitroxides than burning natural gas. And all of those categories, obviously CO2 affects global warming. The other two can be harmful to human health. So while natural gas is a fossil fuel, it is not the worst fossil fuel to be burning, but that doesn't mean that it's green. Natural gas is a fossil fuel. It does create carbon dioxide. It does create those other pollutants, but it is not as bad as coal. The other problem with natural gas is, so it's clean burning, so the emission rates are lower than coal, but with natural gas itself is mostly methane. And anytime there's a natural gas leak, so whether that's during production of natural gas or as it's being distributed, methane is even better at capturing heat in the atmosphere than carbon dioxide. So those methane leaks, even if they're small and not very many of them, or they're just a little bit, that methane is a big contributor to global warming. So natural gas in that not green category, even if it is a little better than burning coal for power. So let's zoom in a little bit to South Florida. Where does South Florida get their electricity? This is a map that comes from the US Energy Information Administration. They make this tool that allows you to look around the country and see different energy resources. So I've pulled up zoomed in on a section of South Florida here. And you can see on this map that the green dots, those are biomass power plants. The blue flames, that's natural gas. That one purple circle down in Homestead, that is the Turkey Point nuclear plant. You have the two petroleum power plants in the Keys, and then those yellow circles that are solar. When you look at it this way, just looking at the number of different power plants and what they use to get their energy in South Florida, it looks like our energy is pretty green. There looks like there are a lot of those not fossil fuel power plants in Florida. It seems like maybe we're doing pretty okay, maybe even more green than fossil fuels. But when you look at the amount of energy that is being made at these power plants, you can see that most of our energy is being generated at those natural gas power plants. And there are a lot of reasons for that. Natural gas is a very energy dense fuel. And all of our infrastructure currently is set up for natural gas. So the power plants already exist and the pipelines and everything else. So running those plants means not a lot of extra investment has to be made before they can operate. They just have to be maintained. And versus these other power options, which come with not only that initial cost of infrastructure, but they also come with a whole host of other problems that have to be addressed. And when you look at also, if you look at the different amounts that each power plant generates, each natural gas power plant generates around 1,500 megawatts per power plant versus an average on biomass or solar, you get a number that's closer to 50 megawatts. So there's a huge difference there. But you can notice that purple section of the pie, that is one nuclear plant. So that is just Turkey Point there, making almost 20% of South Florida's energy. So Turkey Point and that one nuclear plant is making a lot of power, more than any of the natural gas power plants. So just because it is not fossil fuel doesn't mean there's not a possibility for a lot of energy to be made. We'll talk about nuclear a little bit later, but that has other problems, of course. So what is green energy? We talked about what isn't fossil fuels, but what is? So when you hear about green energy, you talk a lot about renewable versus zero or low emission. So renewable, a lot of times you hear it used interchangeably with green. It's green, it's renewable. But what renewable really means is that it's a fuel source that can't be used up. So gasoline and coal, those are finite resources. They can be used up and we will eventually run out, versus these other fuel sources, solar, hydroelectric, geothermal, and wind, we don't use them up. We're not likely to ever run out of those resources. So they'll be able to meet our long-term energy needs, theoretically indefinitely. Then on the other hand, of course, you have zero or low emissions, and that refers to just air pollution, whether or not they create carbon dioxide gas as they're making energy. And so when you talk, if you want to talk about the greenness in terms of our atmosphere and the health of our atmosphere and the health of our planet, and that is zero emissions. The energy resources that I have highlighted in black are the resources we have here in South Florida. The gray ones we do not have down here. So I'm going to talk a little bit more about those three: biomass, solar, and nuclear. So biomass energy. Biomass is energy that comes from plants and animals. So it's a renewable resource where I'm not likely to run out of it. It's kind of a catch-all term. There are lots of different things that fall under that category of biomass, including wood, agricultural crops and waste material, biogenic material in municipal solid waste, so that's the organic stuff in a landfill, animal manure and human sewage all fall under that category of biomass. And for the most part, there are a number of different ways that biomass can be converted into usable energy. But the most common way is direct combustion. So that's burning. And when you burn something, you get emissions, almost by definition. So that carbon emission, those carbon biomass energy does create carbon emissions. It does create other kinds of air pollution, because you're usually, in most cases, you are directly burning that material. But that's not the whole story. Because plants take in carbon dioxide as a part of their natural growing cycle. So plants take in that CO2 as they grow, and they sequester that carbon. So there are the Intergovernmental Panel on Climate Change, which is a UN body that talks about these things, actually says that biomass fuel is net zero emissions, meaning that they feel that the CO2 captured during when the plant is alive is canceled out the emissions created when you burn that for fuel. However, that doesn't tell the whole story about land use practices. So when a forest is cleared for agricultural crops, for instance, corn, there is oftentimes a net loss in the ability of that ecosystem to trap carbon. Most forest ecosystems are able to trap more carbon and store more carbon than agricultural land. So if you're clear cutting a forest in order to plant crops to burn for biomass to fuel, in order to power biomass power plants, there is you end up creating more carbon and more air pollution than the plants are taking in. So that's something to be considered. And in fact, a recent study found that it looked into the US renewable fuel standards. That's a legislation that requires more ethanol to be mixed into gasoline in order to make that fuel more renewable, but also it claimed to help try and cut down on emissions. And that study found that when you take everything into account, including the increase of corn production that the standard led to, and the changes in crop rotation practices and the changes in fertilizer use, that actually the creation of ethanol, if you take in all of the life cycle portions, comes out as 25% worse than gasoline in terms of emissions. So the creation of ethanol was even worse than if they would have just burned gasoline. Now, that doesn't mean that no biomass is green, or that all biomass should be thrown out of the categorization of green, because most of South Florida's biomass comes from that municipal landfills and wastewater treatment plants. So these are actually at these facilities, they are capturing the gases and that this decomposing stuff creates. They're using that biological material in order to create energy. So you're not clear cutting a forest in order to grow corn to make ethanol. In most of the power plants here in South Florida, you're taking something that was already a waste product. It was already garbage. It was already sewage, and then using that to create energy. So there's no land use practice change going on. And in fact, you're taking something that is even more dangerous. A lot of times landfills create that methane gas, and you're turning it into carbon dioxide, which, while it's bad, at least it's not as bad as methane, and we're getting energy out of it. But the problems with changes in land use practice do come into play if we were to try to expand Florida's biomass energy. If we were to say, Florida is going to use biomass energy to replace our reliance on fossil fuels, in that case, there might be a problem of, well, where is that energy? Where is that biomass coming from? Where are we getting those plants? And are we changing the way that we're using our land in order to grow plants specifically to use for fuel? All right, so the next thing we're going to talk about is nuclear energy. So nuclear energy is where you use fission to create heat, which creates steam, to create heat to heat water and making steam, and then using that steam to turn turbines, which creates energy. But nuclear energy requires uranium ore. So uranium ore being a non-renewable resource, but there is nothing burning, there's no combustion happening, so there is no greenhouse gas emissions. So if you look at that picture on the right, that structure that looks like a smokestack is a cooling tower, and the stuff coming out of it is not smoke, but it's actually water droplets. So it's much closer to a cloud than anything else. So often nuclear plants are often considered to be zero emissions because of they don't, in that nuclear fission process, there is no carbon created, there is little to no air pollution created. But of course, the non-renewables part of nuclear energy is not the only black mark it has against it in terms of its greenness. When you use nuclear power to create energy, you get nuclear waste. And in this country, we don't have a storage facility for high-level nuclear waste, so it is just piling up around the country and including at Turkey Point. There is no facility currently to store as permanent storage for high-level nuclear waste, so it's sitting in temporary storage facilities around the country, which is obviously not a sustainable long-term solution to something that is dangerous to people and the environment and will be dangerous for a long, long time to come. But Turkey Point has its own problems. Turkey Point is pretty unique in the country for the way that it is built and the way that it functions. It has these huge man-made cooling canals that have become an environment that is occupied by a number of different species, including the American crocodile, who has very happily taken up residence in the Turkey Point cooling canals. And this on itself is not a problem, and maybe even a good thing. Crocodiles are threatened and they need a place to be. However, since the Turkey Point opened, those cooling canals, which are a mostly supposedly closed system, have been getting increasingly salty. The salinity has been rising by 5% a decade in the Turkey Point cooling canals. And this is not ideal. It scientists suspect that it has had an effect on clutch size. As the salinity goes up, the number of eggs laid by these crocodiles that live in these canals has gone down. And especially on those hot years when the salinity increases more rapidly, the clutch size, they've noticed a dip in clutch size in those years. They don't have enough data yet to fully make those conclusions, but while Turkey Point likes to brag that they have all of this land that is being that is providing habitat for endangered species, that it's not always that clear cut. But in addition to that, a few years ago there was an article, written that showed that there was tritium, a radioactive isotope that was found in Biscayne Bay, suggesting that the cooling canals are leaking into the bay. And obviously, no one wants radioactive water leaking out and contaminating Biscayne Bay. It's a resource that we all love and enjoy and very much like to not be irradiated. So a judge in Tallahassee has ordered FPL to clean up their canals, and that process is ongoing. But the problem of nuclear waste means that even though nuclear power does create so much energy, it is one of the harder ones to obviously it's a hard one to build new plants up because nobody wants to have a nuclear plant in their backyard. Nobody wants to be a neighbor of a nuclear plant, despite the fact that they have been shown to be very safe. And in fact, some sources say that they they're less dangerous to live near than a coal plant. But also no one wants to live near a coal plant. So those arguments don't always work very well. All right, so then the last thing we're going to talk about is our least controversial power source, solar. So solar, you either have two main types, solar thermal power or photovoltaic. Here in South Florida, all of our solar plants are photovoltaic. Those are the ones with the big solar panels. The thermal power actually works using the solar energy to heat water to turn turbines in a similar way of that nuclear energy also heats water and turns turbines. But all of our power plants here use the photovoltaic, so those big solar panels. It is renewable. We're not likely to run out of sunshine and zero emissions, so it falls into both of those big categories of green energy. The problems with solar power are not they're not green, but that solar power can be challenging to work with. It's not constant. The sun doesn't always shine the same amount everywhere. And the amount of sunlight that hits any one space is not very much. The amount of solar energy hitting the surface of any one area is not very much. So you need a lot of space to generate enough energy to keep the lights on. You need a lot of space. Solar plants tend to need a lot of space in order to generate the power that we expect a power plant to generate. And also the technology is fairly new, so they can be very expensive to put in and expensive to install the infrastructure that you need to make them work. So most solar plants in South Florida don't generate very much energy, with some of them generating as little as 1 megawatt. But those small facilities happen to be in places that we don't expect. So this is two different solar plants here in South Florida, one of them on top of the roof of IKEA Miami, and the other one at FIU. So the IKEA solar panels are covering the roof, so space that would otherwise have nothing on it anyway. So that space is being taken up by those solar panels now. And FIU solar panels actually provide shade for 400 parking spaces. So that much coveted shaded parking is now being provided at the same time that FIU is getting 1.4 megawatts of power from them, which I think is pretty cool. And that makes me think about solar potential in Florida. So there's a lot of untapped potential down here. There was a study in 2016 by the National Renewables Energy Laboratory that found that if solar panels were installed on every suitable roof in Florida, so they used LiDAR, they looked at the roofs, they said if every roof that could have solar panels did have solar panels, then Florida could generate 103.2 terawatt hours annually, which is a huge number and enough solar power to cover 46.5, so about half of the state's energy sales. Now, Florida has very high energy demands. We use a lot of energy to cool our homes and that sort of thing, but still to have enough power to cover half of the energy sales is huge. And the interesting thing about this study is that it actually found that there was the most potential in small buildings. So while those great big solar panels on IKEA and FIU are great and fantastic and should be celebrated, they found that there are so many more small buildings across the country that if you focus energy on just helping people and helping communities install small solar panels on buildings, that would have a much bigger impact in switching our energy supply to solar than focusing only on those big projects, those big industrial level and utility level projects. But that comes with a caveat, of course, because you don't just need energy when the sun shines. So one of the solutions to that is storage. So this is an FPL battery in Wynwood. It looks like a huge building, but it's actually a 10 megawatt battery that they've put up in Wynwood that FPL says can power 7,000 homes for 4 hours. In the big picture, 7,000 homes for 4 hours doesn't seem like very much, but battery technology is only getting better, and hopefully in the near future, it will be more affordable and possible for smaller places to have batteries and that enable solar to be more widespread. And obviously, even today, solar panels are a viable choice for consumers. They are getting cheaper all the time, and solar power is one of the greenest choices that Florida can make to cut down on our fossil fuels and make our energy better for the environment, which of course makes it better for us for the future. Our energy use has to change. So what can you do? So hopefully I have helped to clear up a little bit about what green energy is, help you make your decision about what energy sources you support and would be in favor of. And so if it comes up in a local election or there are in your local community, hopefully you can advocate now for greener energy policies and encourage your community or your workplace to make greener energy choices, whether that is, calling for solar panels to be installed at your workplace, or really simple, small decisions like making sure the lights are turned off and trying to use greener appliances. That works at home too, is that if we can cut down on our electricity use, maybe turning the thermostat to a warmer temperature and not using the AC as much, that can cut down on energy use, which can make some of these greener options more viable in more areas. And of course, if you're in a position, installing solar panels is a great option. However, FPL has successfully lobbied to get the tax benefits and the benefits for the financial benefits for installing solar panels to go away. I believe it's in the near future. So that's something that makes things challenging. All right, so back to the poll. What did you learn? Those same questions again. Nuclear power creates low air pollution emissions, true or false? Most of Florida electricity comes from biomass, natural gas, nuclear, or solar. Small solar arrays on individual houses won't have an impact on climate change, true or false? And our last question, do you intend to apply the information that you've learned in the future? You can put what you feel.
All right, we'll give it a few more seconds and then we'll move on. All right. So Allie, do you want to go through this poll?
All right. So nuclear power creates low air pollution emissions. That is true. Then most Florida electricity comes from that's natural gas. B, 3, small solar arrays on individual houses won't have an impact on climate change is of course false. They'll have an impact if every small building that can have solar panels does. That's 50% of our energy use here in Florida. And obviously the fourth one is your opinion. But
All right.
thank you.
All right. Well, thanks, Allie. That was really informative and, really tailored to Florida. I really enjoyed learning a little bit more about kind of where our energy comes from. So it's 6:30, a little after 6:30. So if you have to sign off, that's totally fine. We thank you guys for joining us, and we are going to take some time to answer questions. But of course, if you have any follow-up, you can always email Allie. She has her email here on the screen. And then, of course, follow us on social media. And like I said at the beginning, we have this recorded, so we'll go ahead and send that link out in the next few days. But yeah, let's go ahead and see. I think we have some questions already. Anna, do you